It has been there for as long as the Earth has turned, hanging in the dark, patient and immense. Older than the mountains, older than the oceans, older even than the idea of life itself. We call it Jupiter, a name borrowed from myth, a title whispered up through thousands of years of human awe. But before we named it, before our ancestors knew there were other worlds drifting around the sun, it was simply there, a great light in the night sky, sometimes outshining all the stars. Through the slow turning of human history, people have looked up and seen that light, bright, steady, untwinkling, and felt something. Not just curiosity, not just beauty, but the weight of presence. For Jupiter is not like the others. Mars gleams red, small and fierce. Venus burns white and hot. Saturn wears its rings like a crown of ice. But Jupiter is different. It is huge, rounded, calm in its distant brilliance. Even without knowing its size, without measuring its gravity, people sensed its bigness, not just in the physical sense, but in a way that felt alive. Today, we know the facts. Jupiter is more than 11 times the width of Earth. It could swallow every other planet in the solar system and still have room. It spins so fast that its day lasts less than 10 hours, yet it holds storms that have lasted centuries. It pulls on comets and asteroids with a force that can alter their paths entirely. It is the king of planets, a gravitational anchor for the inner worlds. And yet, despite its speed, despite its storms, it seems quiet. From Earth, we never hear its winds. We never feel its magnetism on our skin. It is distant enough that light itself takes nearly an hour to travel from Jupiter to here. The vast storms, the great belts of cloud, all move in a silence so total that it almost feels deliberate, as if the giant is not a violent place, but a place of deep rest. This is where the thought begins to form. What if Jupiter is not simply a sphere of gas and storms? What if it is something else? Something vast, something conscious, something that has been here all along, simply sleeping, a sleeping god. The idea is older than you might think. Ancient peoples imagined their gods as not always fully awake, not always fully engaged with human affairs. Gods might withdraw into themselves for ages, letting the world run its course. In some stories, they dream creation into being. In others, they wake only in moments of upheaval. And there is something about Jupiter that fits this old pattern, the sense of a watchful power in repose. Think of it. Jupiter does not blaze with fusion like the sun. It does not tear through the heavens like a comet. It simply turns endlessly, holding court with its many moons, shaping the space around it in ways subtle and profound. Its storms could be breathing. Its magnetic field could be a kind of heartbeat. Its shifting clouds, soft, flowing bands of browns, creams, and rust, could be thoughts moving through a vast and layered mind. This is not science, not yet. It is a way of seeing, a metaphor. But metaphors have always been part of how we understand the universe. They are not a replacement for truth, but a bridge toward it. And sometimes, when the scale of something is so far beyond human experience, the only way to feel it is to imagine it alive. The science, however, is no less wondrous. Jupiter radiates more heat than it receives from the sun. Its vast atmosphere churns with patterns that defy simple explanation. Deep within, pressures crush matter into states we cannot replicate on Earth. Perhaps a sea of liquid metallic hydrogen, perhaps stranger still. Its gravitational influence extends far beyond its physical size, bending the paths of worlds, deciding the fate of countless smaller bodies. It is the largest single object in the solar system after the sun, and yet it is not a star. Not quite. Astronomers call it a failed star, but perhaps that's the wrong frame. Perhaps it has not failed at all. Perhaps Jupiter was always meant to be what it is, not a source of blinding light, but a presence, a quiet anchor, a sleeping power in the cold dark. When you look at it through a telescope, even a small one, the feeling is hard to describe. The disk resolves into colors, pale yellows, deep ochres, hints of red and gold, all wrapped in stripes. Sometimes you can see the great red spot, a storm larger than Earth. And if you're lucky, you'll catch the points of light nearby, its moons. 4 of them are bright enough to see with even the most modest optics. They orbit like attendants, never straying far from their master. Galileo was the first to record these moons, and the discovery changed everything. It showed that not everything orbits Earth, shattering the geocentric model of the cosmos. In a way, Jupiter's quiet presence shook the foundations of human thought, a subtle reminder that our place in the universe is not the center, but part of a vast, interconnected dance. And still, Jupiter turns, through the birth and death of empires, through ice ages and warm ages, through the rise of language, art, and science. It has been there in the night, steady as a thought you cannot quite remember but never forget. Some nights, when the sky is clear and you see that bright point, you may feel the strangeness of it. You are looking at a world so large it defies direct comprehension. A world that, in every moment of your life, has been there, holding the balance of things without your noticing. And maybe, in that moment, you will understand why some have thought of it as a god. Not a god in the sense of one who demands worship or sends thunderbolts, though the myths cast him that way, but a god in the sense of an unfathomable being, present beyond the span of human lives, shaping the conditions that make our existence possible. A god who perhaps is not awake. Not yet. Not in the way we think of wakefulness. What would it mean if Jupiter were alive? Not metaphorically, not poetically, but in a way that could be measured. Some form of vast, slow consciousness as different from ours as ours is from the mind of an oak tree. And what would it mean if that consciousness was not active, but dreaming? When you stand outside at night, and Jupiter is high in the sky, the air is quiet. The stars will slowly. And there it is, distant, luminous, unblinking. If you let your mind be still, you might imagine the deep rumble of its slow rotation, the hush of its endless clouds, the whisper of its magnetic field brushing across the solar wind. You might imagine that it breathes, and that somewhere in that breath, a dream continues, a dream that has been unfolding for billions of years. We are so used to thinking of life as something fragile, small, confined to the thin biosphere of Earth. Long before the first telescope turned toward the sky, Jupiter already had a place in the human imagination. It was not just a bright point in the heavens. It was someone. To the Babylonians, it was Marduk, a god of order who battled the chaos dragon Tiamat and shaped the world from her remains. To the Greeks, it was Zeus, king of the Olympian gods, wielder of lightning, ruler of both sky and justice. To the Romans, inheriting the Greek vision, it became Jupiter, or Iupiter Optimus Maximus, the greatest and best of all gods, guardian of Rome, keeper of oaths, punisher of perjury. The naming was never arbitrary. Across cultures, the brightest wanderers in the night sky were given the names of deities. But Jupiter, brighter than almost all, larger than all the rest, was almost always the chief among them, the king. Its stately movement, slow and deliberate across the constellations, gave it an air of regal patience. It was not the hasty messenger like Mercury, nor the lover's star like Venus. Jupiter was the great judge in the sky, presiding over the heavens. Even cultures without a direct connection to Rome or Greece felt something similar. In China, it was known as the year star because its motion across the zodiac roughly matched a 12-year cycle, a cycle that became woven into the Chinese zodiac itself. In Vedic tradition, it was called Brihaspati, the teacher of the gods, the planet of wisdom and spiritual counsel. It is striking how often wisdom, order, and power converge in these myths. Jupiter was rarely imagined as a capricious god. Where Mars might rage and Venus might seduce, Jupiter presided with authority. His storms might be fierce, but they were the storms of judgment, not of whim. And yet, mythology also gave him depth and complexity. Zeus was not just a ruler, but a lover, a wanderer, a figure of cunning when needed. In some stories, he was disguised as a swan, a bull, a golden rain, to move unseen in the world of mortals. These myths suggest a being who, though powerful, was also curious, restless, and willing to act in hidden ways. It is tempting to see parallels in the planet itself. Jupiter's face is ever-changing, bands shifting, spots appearing and vanishing, storms swelling and fading, yet all within a framework that feels stable and enduring. It is as if the myths unconsciously reflected the personality of the real object. Why did ancient people personify the planets at all? Perhaps because the sky was a mirror for the human mind. We have always looked for meaning, for agency, for story. When something moves differently from the background stars, when it travels, reverses course, brightens, dims, it catches the human eye and invites the question, who are you? Without spectroscopy or spacecraft, the ancients still sensed something of Jupiter's difference. Its stately progression meant it did not dart about like Mercury, nor vanish quickly like Venus in the twilight. It lingered. It observed. It waited. That waiting became, in story, the patience of a ruler, the deliberation of a god who sees the whole picture before acting. For the Romans, Jupiter was not just a figure in the sky, but a presence in their city. His great temple stood on the Capitoline Hill, a place of both political and religious significance. Victories were celebrated there, oaths sworn, treaties signed under his gaze. To invoke Jupiter's name was to call upon the highest possible witness. To break an oath sworn by him was not just to offend a god, but to unbalance the moral order of the world. These were not small associations. They reveal how deeply the bright planet's slow path across the heavens became woven into the moral and political fabric of human society. In this way, Jupiter was not only a god of the sky, but a god of the human world, a bridge between the vastness above and the affairs below. Over centuries, as cultures shifted and empires rose and fell, the myths evolved. The Greek Zeus became the Roman Jupiter. The Vedic Brihaspati became guru in later Hindu tradition, a guide in astrology and spirituality. The Chinese year star continued to mark the rhythm of time. The same wandering light took on many names, many faces, yet always retained a certain dignity, a sense of governance over cosmic and human order alike. When the telescope came, when Galileo first saw the moons orbiting it in 1610, the myth met the measurement. The discovery did not strip Jupiter of its divine aura, not entirely. If anything, it made the planet more godlike. Now, it was not just a wanderer in the sky, but a miniature system, a ruler of its own domain, attended by worlds. The king of the gods was also the king of planets. Today, we might smile at the old stories, seeing them as beautiful but outdated. We have spectrometers, orbital mechanics, high-resolution imagery. We can calculate wind speeds and magnetic field strengths. But myth has not vanished. It has only changed form. We still speak of planets ruling certain aspects of the sky, of influences and personalities in astrology, of the mighty Jupiter in space documentaries. The old language of reverence lingers. And perhaps it should. For the myths, do not compete with the science. They are another kind of truth, the truth of how humans, for millennia, have felt in the presence of something immense. A truth about our need to see the cosmos not as an indifferent machine, but as a place filled with meaning, presence, even personality. Jupiter, Zeus, Marduk, Brihaspati, your star. Many names, one presence. A giant in the sky, steady through the rise and fall of human civilizations. And in every name, a quiet acknowledgement. We have always known there is something different about it, something worthy of more than just a label, something that, if you listen long enough, might even speak. The myths gave Jupiter a voice. The science will give it detail. But the awe belongs to both. Every star has its threshold, a point where gravity's inward pull becomes so great that matter itself collapses, heating until atoms fuse and the long fire of starlight is born. Jupiter stands just below that threshold. It is the largest planet in our solar system, more massive than all the other planets combined. And yet, compared to even the smallest stars, it is a shadow of what it might have been. Astronomers tell us that if Jupiter had been about 75 to 80 times more massive, its core pressure and temperature would have crossed that fateful line, and it would have ignited. Not as a sun as bright as ours, but as a dim red dwarf, burning slowly for trillions of years. Imagine it, two suns in our sky. The smaller, ruddy Jupiter star rising in the west while the bright, golden sun sets in the east. Our nights washed not in darkness, but in a constant ember glow. Earth's climate, the evolution of life, even the rhythms of our sleep, all would have been utterly different. But Jupiter did not ignite. It swelled to its present immensity and then stopped, as though it had reached exactly the mass it was meant to be, no more, no less. And so it remained a planet, but not an ordinary planet, because Jupiter is still massive enough that it behaves in ways we associate more with stars than with worlds. Deep inside, pressures crush hydrogen into a strange form, liquid metallic hydrogen, a substance so exotic it conducts electricity like a metal. That inner sea may be the source of Jupiter's immense magnetic field, the largest in the solar system. The planet radiates more heat than it receives from the sun. This is not a leftover warmth from creation alone, but an ongoing release of energy from slow gravitational compression. The planet is still settling into itself after billions of years. In this way, Jupiter is not dead and cold like many smaller worlds. It glows faintly in the infrared, like a banked fire still smoldering. It is this quality that makes the idea of a sleeping Jupiter feel so plausible in metaphor. It is not a lifeless rock, nor a burning star, but something in between, a great body holding its energy inward as if dreaming it, rather than spending it. In the realm of astrophysics, Jupiter belongs to a class of objects called gas giants. But there is a continuum beyond them, brown dwarfs. Bodies too massive to be planets, too small to be true stars, yet capable of fusing certain isotopes like deuterium in their youth. Brown dwarfs are sometimes called failed stars, but that phrase carries an assumption that the purpose of a massive body is to burn. Perhaps Jupiter is not failed at all. Perhaps it is simply other. From a cosmic perspective, Jupiter's choice, or fate, to remain a planet rather than a star has shaped everything about our solar system. If it had ignited, the fragile balance of planetary orbits might never have formed as they did. The habitable conditions on Earth might never have emerged. Life, as we know it, might never have arisen to look up at the sky and wonder. In this sense, Jupiter's incompletion is not a shortcoming, but a gift. It is the giant that could have been a sun, but chose instead to be a guardian. Its gravity is the architect of the outer solar system. It sculpts the asteroid belt, deflects comets, stirs the orbits of countless small worlds. In some cases, it sends icy bodies hurtling inward toward the inner planets, delivering water and organic materials. In others, it intercepts potential threats before they can reach us. And yet, despite its influence, it never oversteps its bounds. Jupiter circles the Sun like any other planet, bound by the same laws, never dominating the system entirely, never collapsing into a star's central authority. It is as if it is content to reign without ruling, to shape without consuming. From a scientific lens, all of this is the outcome of mass, chemistry, and gravity. From a poetic lens, it feels like restraint, a god who sleeps, rather than rising to the throne of light. There is a beauty in the almost of Jupiter, in the fact that it sits at the edge of a different destiny, yet stays where it is. It carries within it the potential for a second sun, yet keeps that fire folded deep inside, locked away under layers of cloud and pressure. When astronomers discover planets around other stars, they often find hot Jupiters, gas giants orbiting perilously close to their suns, their atmospheres boiling away. Some are swollen to many times Jupiter's size, and some may have once been near that threshold of becoming stars themselves. But our Jupiter remains far out, where it can hold on to its clouds and its moons, serene in the cold. It is almost as though, from the moment of its formation, it was set apart, meant not to shine in the way stars shine, but to shine in another way. Through its influence, through its presence, through the quiet balance it keeps in the architecture of our system. When you think of Jupiter as the planet that could have been a star, it is tempting to feel a sense of missed grandeur, the loss of a binary sky. But if we look closer, we see that this is exactly the grandeur we needed. The light of a star can be too much. The pull of a second sun could have torn our fragile home from its orbit or bathed it in a constant, sterile heat. Jupiter's silence, its non-burning, is part of what made Earth possible. So perhaps it is not a failed star. Perhaps it is a star that chose not to wake. A giant lying at the edge of light, content to let others blaze, content to drift in its own deep dreams. And somewhere in those dreams, perhaps it remembers what it might have been and knows that what it is better. When we look at Jupiter, we see clouds, bright bands of white and ochre, curling storms, the great red spot, like a restless eye. But beyond that visible beauty lies something we cannot see with human eyes, an invisible web that stretches far beyond the planet itself. It is a magnetic field, the largest and most powerful of any planet in our solar system. It begins deep inside Jupiter, where pressures crush hydrogen into a strange metallic state. This metallic hydrogen flows like a vast ocean of liquid metal, conducting electricity on a planetary scale. From this movement, a magnetic field is born, and not a gentle one. Jupiter's magnetic field is 14 times stronger than Earth's, and it does not end neatly at the planet's edge. It stretches outward, ballooning into space in an enormous bubble called the magnetosphere. This bubble is so large that if it were visible from Earth, it would appear bigger than the moon in our night sky, even though Jupiter itself is hundreds of millions of kilometers away. Inside this magnetosphere, space is not empty. It is filled with particles, electrons, protons, ions, trapped and accelerated by Jupiter's magnetic embrace. They spiral along invisible lines of force, moving in intricate patterns dictated by physics as old as the universe. These particles form radiation belts far more intense than anything around Earth. To spacecraft, they are deadly. To the human body, they would be catastrophic. And yet, to Jupiter, they are simply part of its nature, like a halo, constantly renewed by volcanic material thrown into space from its moon, Io. Io is restless, molten beneath its surface, and its eruptions release vast amounts of sulfur and oxygen into space. These particles are swept up by Jupiter's magnetic field, drawn into its invisible currents, adding color and substance to its unseen realm. This invisible web is not still. It rotates with Jupiter's rapid spin, sweeping around like a cosmic lighthouse. It interacts with the solar wind, that constant outpouring of charged particles from the sun, creating shock waves and currents, shaping the very boundary between Jupiter's realm and interplanetary space. Sometimes the web becomes visible in a way we can see, auroras. At Jupiter's poles, the magnetic field guides charged particles into the upper atmosphere, where they collide with atoms and molecules, releasing light. The result is a ring of glowing energy, not a fleeting display like our auroras on Earth, but a permanent feature. These auroras are hundreds of times more energetic than anything our planet can produce. They are the visible signature of an invisible giant's breath. From a poetic view, Jupiter's magnetic field feels almost like an aura, the unseen presence of a sleeping god. You cannot touch it or see it directly, but you can sense its effects. It pulls, it shapes, it protects its moons, it dominates the space around it. If Jupiter were a person, this field would be its silent influence, the way it changes the world simply by existing. Gravity is part of this web too. Jupiter's mass is so immense that it tugs not just on nearby objects, but on the architecture of the solar system itself. It shepherds asteroids in the asteroid belt, holds dozens of moons in orbit, and may have altered the paths of comets long before humans walked the Earth. Its gravity can fling objects into the inner solar system, or hurl them away entirely. In a very real sense, Jupiter acts as both protector and destroyer. It is the cosmic gatekeeper, deciding which wanderers pass inward toward the sun and which are cast back into the deep. To imagine this invisible web is to picture something vast and alive, not a rigid cage, but a moving, breathing structure. Lines of magnetic force arch and bend. Currents of charged particles spiral and flare. Moons orbit through this environment like fish swimming through ocean currents, feeling invisible tides push and pull at them. The closest analogy on Earth might be standing in a strong wind you cannot see. Only here, the wind is made of invisible threads of energy, and you are surrounded on all sides. In Jupiter's realm, the laws of nature weave patterns that we can only detect with instruments, but which are as real as the clouds in its atmosphere. And the beauty is this. Though invisible to our eyes, this web is always there. It shapes the orbits of moons, drives auroras, feeds storms, and sculpts space itself. It is the part of Jupiter that reaches out, touching worlds far beyond its surface. In mythology, gods often have domains: the sea, the sky, the underworld. Jupiter's domain is both visible and unseen. It is the churning storms and the bright cloud bands. Yes, but it is also the silent, immeasurable reach of its magnetic and gravitational fields. You could drift for millions of kilometers away from the planet and still be within its influence. And so the sleeping god lies there, wrapped in an unseen mantle. The clouds are its skin, but the magnetic field is its breath, flowing outward, invisible yet undeniable. Its gravity is the weight of its presence, the silent pressure that shapes the dance of moons and rocks and dust. It is a reminder that not all power is visible, that influence can extend far beyond where the eye can see, that sometimes the most important forces in the universe are the ones we cannot touch, but can only feel. Jupiter does not drift through the void alone. It moves with a retinue, a vast, intricate company of moons, each circling in its own path, each carrying its own history and secrets. To see them all together is to watch a dance older than civilization, a choreography written in gravity and time. Astronomers have counted over 90 moons in Jupiter's care, from small, irregular rocks barely clinging to its pull to worlds so large they could be planets in their own right. And among them are the 4 great Galilean moons: Io, Europa, Ganymede, and Callisto, first seen by Galileo in 1610 through a small, imperfect telescope. To him, they were points of light, shifting position night after night. To us, they are worlds, each singing with a distinct voice in Jupiter's choir. Io's voice is a restless drumbeat. It is the most volcanically active world in the solar system, its surface a constantly shifting canvas of lava flows and sulfur plains. This is no quiet moon. Beneath its surface, immense tidal forces, caused by Jupiter's gravity and the gravitational tug of its sibling moons, knead Io's interior like dough, generating heat that bursts upward in fountains of molten rock. If you stood there, the ground might tremble beneath you, the sky tinted in yellows and reds from sulfur clouds. Io's song is fire, beating in time with Jupiter's pull. Europa's voice is a whisper. Its surface is a smooth, pale shell of ice, crisscrossed with dark lines, cracks in the frozen crust. Beneath that shell lies something extraordinary, a global ocean, hidden and sealed away from the sunlight, yet kept liquid by the same tidal heating that fuels Io's volcanoes. This ocean may be twice the volume of all Earth's oceans combined, and in its dark waters, life may swim, alien, unseen, waiting. Europa sings softly, a lullaby of water and possibility. Ganymede's voice is deep and resonant. It is the largest moon in the solar system, bigger even than Mercury. Like a quiet giant, Ganymede carries its own magnetic field, the only moon known to do so, wrapping it in a miniature version of Jupiter's invisible web. Its surface tells stories in ice and rock, bright regions scarred by ancient tectonics, darker plains that have endured for billions of years. Ganymede's song is a steady grounding hum, the bass line beneath Jupiter's celestial music. Callisto's voice is the echo of memory. It is the most heavily cratered object in the solar system, its surface virtually unchanged for 4 billion years. In Callisto's scars are preserved the record of the early solar system, of the time when giant impacts were frequent and violent. Unlike its siblings, Callisto is geologically quiet. No volcanoes, no resurfacing, no restless tides. It drifts in serene isolation, carrying the past on its face. Callisto's song is ancient and slow, like a hymn that has been sung since the dawn of time. Beyond these four, the smaller moons add their own faint harmonies. Some are captured asteroids, others fragments of larger moons broken apart in collisions. They orbit in strange, tilted paths, some even moving backward against Jupiter's rotation, as though resisting the giant's spin. Each of them is a note in the vast chord Jupiter plays, brief, high, flickering tones that come and go. Altogether, these moons form a system within a system, a miniature solar system orbiting the giant planet. Their gravitational interactions are complex, each moon tugging on the others, their orbits locked in resonances that create rhythms lasting millions of years. To watch them is to witness a cosmic symphony, where every body has its place, every movement has its timing. Even in silence, this music is real. If you could translate the gravitational forces into sound, you would hear chords shifting slowly over time. Deep bass tones from Jupiter's immense pull, lighter notes from the swift inner moons, long resonances from the outer ones. The solar system is full of such music, but around Jupiter it is especially rich. Sometimes the moons and Jupiter converse directly. Io's volcanic gases feed Jupiter's radiation belts. Europa's ocean interacts with the magnetic field, creating faint electromagnetic waves detectable by spacecraft. Ganymede's magnetosphere brushes against Jupiter's, creating magnetic footprints in Jupiter's auroras, glowing marks where the two fields connect. Even Callisto, distant and quiet, stirs Jupiter's tides in a subtle, constant way. It is tempting to imagine Jupiter as a conductor, standing at the center of this grand orchestra, guiding the timing and energy of each moon's song. But it is just as true that the moons conduct Jupiter in return, pulling at its gravity, shifting its position ever so slightly as they orbit. This is not a one-way performance. It is a duet between the giant and its companions, and together they create something neither could alone. Seen from far away, the whole system is breathtaking. Jupiter turns, wrapped in its belts of cloud, while its moons glide in measured paths, each illuminated by sunlight, each moving through the giant's invisible web of gravity and magnetism. And beyond them, faint rings of dust circle in silence, the quietest harmony of all, a background tone almost too soft to hear. In this choir, no voice is lost. Even the smallest moon adds something to the whole. Even the faintest motion changes the harmony over time. And as the centuries pass, This music continues, not in human lifetimes, but in planetary eras, the kind of time measured in the slow drift of orbits, in the grinding of ice beneath Europa's crust, in the cooling of lava plains on Io. The choir of moons is not just a feature of Jupiter's system. It is a reminder of the relationships that bind celestial bodies together, of how motion and gravity can create not just mechanics, but beauty, of how, in the vastness of space, companionship is possible and even common. To stand beneath Jupiter's sky, if you could, would be to witness a spectacle beyond anything Earth could imagine. There are no calm blue afternoons here, no gentle sunsets. Instead, the atmosphere is an endless canvas of motion, a churning masterpiece painted in ochres, creams, and deep cinnabar reds. From far away, Jupiter's surface, which is no solid surface at all, appears banded with alternating belts and zones. These are powerful jet streams, each thousands of kilometers wide, flowing in opposite directions. Between them, storms are born, grow, and sometimes fade. But on Jupiter, storms are not fleeting events. They can last decades, centuries, perhaps even forever by human reckoning. The most famous of them all is the Great Red Spot, a storm so vast that Earth could fit inside it more than once. It has raged for at least 350 years, and perhaps much longer. Early astronomers saw it through crude telescopes in the 1600s and recorded its presence, but they could not have imagined the sheer scale of the forces at work. The Great Red Spot is a high-pressure system, a colossal vortex spinning counterclockwise in Jupiter's southern hemisphere, surrounded by winds that can reach speeds of over 400 kilometers per hour. Its color, a deep brick red fading sometimes to pale salmon, is still a mystery. Some scientists suspect it comes from complex chemicals formed when ultraviolet sunlight strikes the ammonia clouds, creating compounds that tint the storm's upper layers. Others believe the red is a sign of deeper material being dredged upward from far below. Whatever its source, the Great Red Spot is a beacon, a reminder that on Jupiter, nature plays on a scale beyond our comprehension. Yet, the Great Red Spot is only the most famous member of an entire family of storms. Elsewhere on Jupiter, there are white ovals, smaller but still vast whirlpools of cloud, and chaotic storm clusters, where new systems are born in sudden bursts. Some of these merge to form larger tempests. Others fade, dissolving back into the flowing belts. Lightning flashes in the depths of these clouds, brief and fierce, illuminating the towering thunderheads that rise like mountains from the cloud deck. Unlike Earth's storms, which draw their energy from the sun-warmed oceans and eventually dissipate when they run out of heat, Jupiter's storms are fed by something far more constant, the planet's own internal heat. Jupiter radiates more energy than it receives from the sun, a leftover warmth from its formation 4.5 billion years ago. That heat rises through the deep atmosphere, feeding the convective towers, sustaining the turbulence, and ensuring that storms can persist for generations. In this way, Jupiter's weather is not a cycle with beginnings and ends. It is a perpetual motion, a living, breathing system that does not rest. To a human observer, it might feel eternal. The tempests here are not just meteorological events. They are features of the planet itself, as much a part of Jupiter as the core and the magnetic field. If you could descend into one of these storms, the experience would defy human sense. The clouds would tower above like walls, layered in whites, yellows, and browns, their shadows creating an alien twilight. Winds would tear past in opposite directions at different altitudes, each jet stream a river of air moving at terrifying speed. Deeper still, lightning bolts, larger than continents, would split the darkness, their sound waves lost in the deafening rush of the atmosphere. And below that, deeper than any probe has yet seen, the gases would thicken under crushing pressure, transitioning into strange, exotic states of matter. It is likely that the storms of Jupiter reach depths where hydrogen becomes metallic, conducting electricity and interacting with the planet's magnetic field. In these hidden layers, the storms are no longer clouds in the human sense. They are massive rotating columns of dense, hot fluid anchored deep in the planet's interior. Perhaps it is this anchoring that allows them to survive for centuries. The storms are not isolated, either. They interact, colliding, tearing at each other's edges, sometimes feeding energy from one to another. The Great Red Spot itself has been seen swallowing smaller storms whole, absorbing their energy and growing in the process. It is a predator of the skies, and yet it too is vulnerable. Observations show that it has been shrinking in recent decades. Whether this is the prelude to its fading or simply another turn in its long life, no one knows. But even if the Great Red Spot someday vanishes, Jupiter will not be without storms. New tempests will rise, old ones will merge, and the dance of wind and cloud will continue. This is a planet that knows no calm, only movement, only change. In the vast, silent darkness of space, Jupiter's storms are paradoxical. They are invisible to the ear, yet they carry a music of motion. The jet streams are like the strings of an enormous instrument, plucked by the heat from below. The vortices are the resonant drums, spinning their low, slow rhythms for centuries. If you could translate their patterns into sound, the result might be a deep rolling symphony, shifting and evolving, but never ending. From Earth, we watch through telescopes and spacecraft, catching only glimpses of this vast performance. But for the storms themselves, there is no audience. They are not for us. They are for Jupiter and for the laws of physics that govern them. They are the natural consequence of a giant world with a restless heart, an atmosphere too deep and too vast to ever truly sleep. And so they continue, storms without end, born in heat, sculpted by wind, fading only to rise again. A reminder that in the universe, there are processes far older, far larger, and far more enduring than we can easily grasp. On Jupiter, even the weather has a kind of immortality. When we think of planetary rings, our minds almost always leap to Saturn, to its brilliant icy bands, visible even through a small telescope. Saturn's rings are grand, luminous, and unmistakable. Jupiter's, by contrast, are almost invisible. They are ghostly things, faint as breath on glass, revealed only to those who look closely enough. For centuries, no one suspected Jupiter had rings at all. The great telescopes of the 17th and 18th centuries showed its swirling clouds and dancing moons in stunning detail, but not the delicate halo that surrounds it. It wasn't until 1979, when NASA's Voyager 1 spacecraft flew past the planet, that the truth was revealed. As the probe looked back at Jupiter with the sun behind it, a thin arc of light appeared, the rings catching the sunlight like fine dust drifting in the air. Jupiter's rings are not made of gleaming ice like Saturn's. They are composed mostly of dust, tiny particles no bigger than grains of sand. This dust does not last forever. The constant pull of Jupiter's gravity draws it downward, while the solar wind sweeps it away. And yet, the rings persist because they are continually replenished. The source? The planet's small inner moons. Adrastea, Métis, Amalthea, and Thebe, names from ancient myth, circle close to Jupiter, so close that their surfaces are constantly bombarded by meteoroids. Each impact blasts fine particles into space, and these particles drift into orbit, becoming part of the ring system. The moons are like quiet gardeners, scattering seeds of dust into the planet's halo. There are three main components to the system: the faint halo ring, a thicker main ring, and a pair of gossamer rings that lie farther out. The halo ring is a diffuse, almost spherical cloud of dust close to the planet, invisible except when lit from behind. The main ring is a thin, flat band, denser and more sharply defined. Beyond it lie the gossamer rings, so delicate that their name feels literal. They seem spun from light itself. Unlike Saturn's bright arcs, Jupiter's rings are dark. They reflect very little sunlight, absorbing most of it instead. If you could stand on one of the inner moons and look toward Jupiter, the rings would appear not as glittering bands, but as a faint, smoky veil against the blackness of space. Yet they are beautiful in their own way, subtle, understated, a secret kept between the planet and those who take the time to notice. There is poetry in their origin. These rings are born not from some ancient collision or primordial disk, but from constant renewal. They are the product of countless small impacts, each adding a few grains of dust to the whole. In this way, the rings are always young. No single particle remains for long, but the structure endures. It is a reminder that permanence can arise from continual change, that something fragile can last forever if it is constantly remade. To the spacecraft that have flown through them, the rings are both peril and wonder. The dust within them moves at tremendous speeds, and even a particle the size of a grain of rice could damage a probe if it struck at orbital velocity. For this reason, missions like Galileo and Juno have planned their paths carefully to avoid the densest regions. Still, as they pass through the outer fringes, their instruments sometimes detect the whisper of impacts, the faint tap of dust on metal, the smallest echoes of the ring's presence. In the darkness of Jupiter's shadow, the rings disappear completely, becoming one with the void. But when the sun's rays sweep across them, they return, not with the blinding brilliance of ice, but with a muted glow, like embers glimpsed through smoke. They are quiet, modest, and yet as much a part of Jupiter as the great red spot or its retinue of moons. The gossamer rings, fed by the distant moons Amalthea and Thebe, are perhaps the most ethereal of all. From afar, they are little more than a ghostly outline, but up close, they are a vast, intricate cloud of dust grains, each one following its own delicate path. These paths are shaped not just by Jupiter's gravity, but by its powerful magnetic field, which can pull charged dust particles into complex spirals. Here, gravity and magnetism work together to choreograph a slow, silent dance that has been going on for billions of years. It is tempting to think of Jupiter's rings as an afterthought, a faint echo of Saturn's glory. But in their own way, they are a different kind of marvel. They are not monuments, but whispers. They speak not of grandeur, but of subtlety. They do not proclaim their presence. They invite you to look closer, to see the beauty that hides in the almost invisible. And in this, they mirror the planet they encircle. Jupiter may be the largest world in the solar system, but much of its wonder lies in the details, the turbulent patterns of its clouds, the hidden depths of its storms, the unseen heat that drives its weather. The rings are part of that hidden world, a halo so faint that it exists in the space between perception and imagination. Long after Voyager revealed them, the rings remain difficult to study. Even from space, they can vanish into the blackness unless the lighting is just right. And yet, knowing they are there changes the way we see Jupiter. It is no longer just a gas giant with swirling clouds and a great red eye. It is a world wearing a crown, delicate and understated, as if trying not to draw too much attention to itself. Perhaps in the grand theater of the solar system, Saturn's rings are the triumphant fanfare, and Jupiter's are the soft refrain that lingers after the music fades. They are the part of the song you might miss if you aren't listening closely. But once you hear it, you can't forget. Around Jupiter lies a vast, invisible kingdom, a realm so large that if we could see it with our eyes, it would dwarf everything else in the night sky. This is the magnetosphere, the largest single structure in our solar system created by a planet. It is not made of rock or ice or gas, but of forces, magnetic fields, and charged particles stretched across millions of kilometers. Imagine Jupiter at the center of this unseen empire, its swirling clouds just the bright jewel in the middle of a dark, sprawling crown. The magnetosphere extends far beyond the planet itself, enveloping its moons, sweeping out past the orbit of Saturn in the direction away from the Sun. On the side facing the Sun, it is compressed by the solar wind into a rounded shield. On the far side, it trails away into space for hundreds of millions of kilometers, a magnetic tail so vast it could contain several suns end to end. The magnetosphere begins deep within Jupiter. At its heart lies a core of rock and metal, surrounded by a layer of metallic hydrogen, a strange state of matter that exists only under extreme pressure. Here, hydrogen atoms are so tightly packed that their electrons move freely as they do in metals, allowing them to conduct electricity. Combined with Jupiter's rapid rotation, one day lasting less than 10 Earth hours, this creates a dynamo effect, generating a magnetic field 14 times stronger than Earth's. This magnetic field traps and accelerates charged particles, electrons, protons, and heavier ions, creating belts of radiation that encircle the planet. These radiation belts are so intense that they would fry the electronics of an unshielded spacecraft in hours. They are among the harshest environments in the solar system, rivaling the conditions near the Sun itself. The power of the magnetosphere is not only in its scale, but in the way it shapes the space around Jupiter. As the solar wind, a constant stream of charged particles from the Sun, flows past, it presses against the magnetosphere, distorting it into a teardrop shape. On the day side, the boundary, called the magnetopause, lies just a few million kilometers from the planet. On the night side, the magnetic tail stretches so far that it may reach beyond Saturn's orbit. Jupiter's moons live within this vast magnetic realm, and some, like Io, Europa, and Ganymede, interact with it in remarkable ways. Io, the most volcanically active body in the solar system, spews out vast clouds of sulfur and oxygen. These gases are stripped apart into ions by Jupiter's magnetic field and swept into orbit, forming a donut-shaped cloud called the Io plasma torus. This torus feeds Jupiter's radiation belts and even powers enormous electrical currents between Io and Jupiter itself, currents strong enough to generate intense auroras in the planet's polar regions. Europa, with its hidden ocean beneath an icy crust, feels the tug of the magnetosphere in a different way. As it moves through the field, it generates small electrical currents of its own, hinting at the salty water deep below. Even Ganymede, the largest moon in the solar system, carries its own miniature magnetic field, the only moon known to have one, creating a magnetic bubble inside Jupiter's larger one. The auroras of Jupiter are unlike any seen on Earth. On our world, the northern and southern lights are rare, fleeting events, visible only when the solar wind is strong. On Jupiter, they are permanent. Even without the Sun's input, the interactions between the planet's magnetic field and its moons produce shimmering ovals of ultraviolet light around each pole. To the human eye, they would be ghostly bluish curtains rippling against the darkness, vast enough to cover the entire surface of our planet. Inside the magnetosphere, space is never truly empty. Particles spiral along magnetic field lines, colliding, accelerating, sometimes slamming into the upper atmosphere at near-light speeds. Here, the invisible is constantly at work, shaping the radiation environment, affecting the weather of Jupiter's upper layers, and even influencing its cloud patterns in ways scientists are still unraveling. The scale of this invisible giant defies easy comprehension. If we could see the magnetosphere from Earth, Jupiter would not appear as a point of light in the night sky. It would stretch across a space so large that it might eclipse the Moon itself. It is the unseen half of the planet's presence, the vast shadow it casts, not in light, but in magnetic force. For spacecraft entering Jupiter's magnetosphere, it is like stepping into a storm without clouds. Galileo, the probe that orbited the planet in the 1990s and early 2000s, endured years of intense radiation, its electronics slowly degrading despite heavy shielding. The Juno spacecraft, currently in orbit, flies in a highly elliptical path, diving in close to Jupiter for brief moments before retreating to safer distances. Each pass is a calculated gamble, a dance at the edge of the invisible giant's reach. And yet, there is beauty here too. The magnetosphere is not just a shield or a trap, it is a sculptor of worlds. It shapes the surfaces and atmospheres of moons, powers auroras, and carries the echoes of volcanic plumes and oceanic tides across millions of kilometers. It binds Jupiter's system together in a web of forces, an unseen architecture as intricate as the planet's visible clouds. In the end, the magnetosphere is a reminder that much of the universe is hidden from our eyes. The most powerful structures may be those we cannot see, forces that move silently through space, vast and patient, influencing everything they touch. Jupiter's magnetosphere is such a force, a giant without a face, a king whose crown is made of invisible lines, a storm that will rage as long as the planet spins. In the cold darkness of the outer solar system, where sunlight is thin and pale, there is still a place where light dances endlessly. At Jupiter's poles, luminous rings shimmer and swirl, auroras that never fade, never sleep. They are not rare flickers like the northern and southern lights of Earth. They are permanent, ceaseless crowns of energy, encircling the planet's magnetic poles as if marking it with celestial fire. Seen in ultraviolet light by distant instruments, they blaze like halos of ghostly violet and blue, pulsing with the rhythm of unseen currents. To the human eye, standing impossibly close above the Jovian clouds, they would appear as towering curtains of pale luminescence, vast arcs bending with the curve of the horizon, their edges rippling like silk in a wind that cannot be felt. Auroras on Earth are the handiwork of the sun-charged particles from the solar wind strike our atmosphere, exciting atoms and molecules until they glow. But on Jupiter, the story is different. The sun plays only a supporting role. Here, the magnetosphere itself is the main artist, and the moons are its collaborators. The most dramatic of these collaborators is Io, the volcanic world whose surface is scarred by molten rivers and sulfur plains. Every second, Io ejects a ton of gas into space, a mix of sulfur and oxygen that is stripped into ions and swept into the vast magnetic embrace of Jupiter. As Io moves through the field, it generates a massive electrical current, a circuit linking moon to planet. This current races along magnetic field lines, slamming into Jupiter's upper atmosphere at the poles, where it explodes into radiant arcs of light. These Io footprints, as scientists call them, are visible even within the broader auroras. They appear as glowing spots, shifting position with the moon's orbit, like bright embers embedded in a ring of flame. Europa and Ganymede have their own footprints, though fainter, proof that each moon tugs at the magnetic field in its own way, leaving luminous signatures in the polar skies. Unlike Earth's auroras, which come and go, Jupiter's are powered constantly. The planet's fast rotation, combined with its vast magnetic field, acts like an enormous generator, accelerating charged particles to incredible speeds. Some are solar particles trapped in the field, others are born from the volcanic breath of Io. All spiral along magnetic field lines, funneled toward the poles, where they strike hydrogen molecules in the upper atmosphere, making them glow. The result is a light show, both alien and eternal. If we could drift above the poles, we would see the auroras as glowing ovals, circling like the rings of Saturn, but made of pure light. Their colors would shift subtly, from soft white to pale blue to deep violet, as different energies excite different gases. Within them, arcs and curls would twist and fade as if invisible hands were sculpting the light. Beneath the auroras, the clouds of Jupiter swirl in muted golds and browns, their movement slow compared to the frenetic dance above. Lightning flashes in the deeper layers, but it is lost against the grandeur of the lights at the top of the world. It is as though the planet wears a crown, not of jewels, but of energy itself, visible proof of the power coursing through its magnetic heart. Even from millions of kilometers away, spacecraft instruments can detect the signature of these auroras. They are bright in ultraviolet, strong in X-rays, even audible in radio waves. To radio telescopes, Jupiter's auroras sing, bursts of static and whistles, changing as the moons move through their orbits. Each song is a record of magnetic storms, moon interactions, and the ceaseless motion of charged particles. The scale of these auroras is staggering. The largest ovals can be bigger than Earth itself. A single arc could span the distance from New York to Tokyo many times over. And yet, they are delicate, their shapes changing in minutes, their edges fading into the blackness of space. The auroras are also a reminder that beauty in the universe is often the byproduct of violence. The charged particles that create them are moving at incredible speeds, accelerated by forces strong enough to strip the atmosphere from a lesser world. They crash into the upper air with enough energy to alter its chemistry, creating heat, breaking apart molecules. To any living thing, they would be deadly. Yet to the eye, they are pure grace, a visual symphony of collision and motion. Jupiter's auroras are more than just decoration. They are clues. By studying them, scientists learn about the invisible structure of the magnetosphere, the nature of the solar wind in the outer solar system, and the hidden processes on moons like Io and Europa. Each flicker of light is a message from the planet's invisible giant, a code written in brightness and shadow. And so, the crown of the king glows on, day and night, year after year. It will shine for as long as Jupiter spins, for as long as Io's volcanoes breathe, for as long as the sun's faint wind brushes against this magnetic realm. If the great red spot is Jupiter's face, then the auroras are its soul, unseen from afar, yet full of restless, endless life. In them, the planet's hidden forces reveal themselves, turning the polar skies into a stage where light itself performs without pause. It is said that every god has a heartbeat. For Jupiter, that heartbeat is not a sound, but a motion, a great churning rhythm in its endless atmosphere. And if the planet is a sleeping god, then the great red spot is the slow turn of its dreaming mind. Seen from space, it looks like an eye the size of worlds, more than twice the diameter of Earth, staring outward without ever blinking. It is not a perfect circle, but an oval, streaked with shades of crimson, rust, and pale orange, framed by white cloud bands that swirl endlessly around it. This storm has been raging for at least 3 centuries, perhaps far longer. No human alive today was born when it began. No human will live to see its true end. Step closer in your mind and imagine the winds. Within the red spot, they reach speeds of over 400 kilometers per hour, stronger than any hurricane Earth has ever known. The clouds here are made of ammonia ice crystals and darker compounds, still not fully understood, stirred into constant motion by heat rising from below and the fierce rotation of the planet. These clouds never rest. They are shredded, stretched, folded over themselves in a dance of turbulent beauty. To peer into the storm is to look into a wound in Jupiter's skin, a wound that never closes. Like the eye of a cosmic predator, it stares not with sight, but with presence. Everything around it bends to its spin. Smaller storms are pulled in and swallowed. Streaks of cloud are wrapped into spirals, belts, and zones that stretch across the planet's circumference, curve gently as they pass by, as though bowing to the storm's command. It is not a storm in the earthly sense. On our planet, storms are transient. They are born, they rage, they fade. But here, the great red spot exists outside that cycle. It is a fixture, not a visitor. The forces that feed it are woven into the very physics of Jupiter itself. The lack of solid ground, the planet's rapid rotation, the heat that wells upward from its interior, and the complex, layered atmosphere that shifts and shears at different altitudes. There is something hypnotic about the thought. This same storm has been spinning for as long as the modern human world has existed. While we built cities, while we fought wars, while we invented the telescope and the radio, the red spot turned on. Always there, always moving. It has watched our history from a distance, unchanging in its own place, beyond the reach of our seasons and centuries. Scientists have watched it change shape, though. It is shrinking, slowly, steadily, a reminder that even the longest-lived storms eventually end. In the late 1800s, it was nearly 50,000 kilometers across. Today, it is closer to 16,000. Still vast enough to swallow our world whole, but diminished from its peak. Some wonder if it is finally dying. Others suspect it will find a way to renew itself, drawing strength from the deep, chaotic currents of the Jovian atmosphere. Its colors shift too. Sometimes it deepens into a rich, blood-like red. At other times, it fades to a pale salmon or even beige. These changes may come from the chemistry of the upper atmosphere, sunlight breaking apart molecules, storms dredging up darker material from below. It is as though the storm is breathing in color, exhaling it again, revealing moods we cannot truly read. If you could stand above it, impossible, but imagine, the scale would be incomprehensible. You would not hear thunder, for there is no ground for echoes. You would not feel rain, for the moisture here is ammonia and water in icy crystals, whipped too fast to fall. Instead, you would see bands of cloud moving at speeds that defy human experience, spiraling toward the edge of the vortex. You would sense the power of an atmosphere unbound, a sky that has never been broken by mountains or seas. And you would feel something else, an uncanny stillness at the storm's center. Like all cyclones, the great red spot has an eye, but this eye is not calm in the earthly way. Here, the stillness is relative, a slow rotation compared to the furious winds just beyond. Looking into it would be like looking into the quiet core of a galaxy, knowing that everything around it is in motion, far beyond your grasp. In the myth of the sleeping god, the great red spot is not just an eye. It is the god's dream turning in place. It is the thought that cannot be erased. Around it, the rest of the planet's storms shift and change, appearing and vanishing in days or weeks, yet this one remains. It is the anchor, the memory, the part of the god that will not yield to time. Yet even here, eternity is not guaranteed. Perhaps in 100 years, perhaps in 1,000, the red spot will fade into the surrounding clouds. It will become just another swirl among many, unrecognizable except in the records of those who watched it from afar. And in that fading, Jupiter will lose one of its oldest features, a change invisible to the naked eye, but immense in the history of the planet. Until then, it turns, and turns, and turns. From the outside, it looks like violence, a furious storm tearing at itself without pause. But from a great distance, it is strangely graceful. The bands around it flow like ribbons in water. Smaller vortices form and dissolve at its edges, drawn in by its vast gravity of motion. And in that slow, patient spin, there is a kind of beauty. The beauty of something too large for us to control, too ancient for us to measure in human years. For the sleeping god, this is not fury. This is simply the way it dreams. Beyond the dance of moons, beyond the shimmering auroras at the poles, Jupiter's magnetosphere stretches outward into a form that few imagine when they think of planets. It is not a perfect sphere. It is not even symmetrical. It is a living shape, sculpted by the sun's breath. The sun sends out a constant wind, a stream of charged particles that rushes through the solar system at hundreds of kilometers per second. When this solar wind meets Jupiter's immense magnetic field, it presses against it, compressing the side facing the sun into a rounded shield. But on the opposite side, the night side, the magnetosphere is stretched and drawn out into a vast, tapering structure, the magnetotail. It is here, in the dark wake of Jupiter, that the magnetic field is pulled into long, slender lines, reaching millions of kilometers into space. Some estimates suggest that Jupiter's magnetotail may extend as far as Saturn's orbit, a ghostly bridge between worlds. In this shadow realm, the rules of motion and energy are different. It is a place where invisible rivers of charged particles flow backward, away from the sun, caught in the tension of stretched magnetic lines. The magnetotail is not empty. It carries with it the signatures of Jupiter's moons, the whispers of volcanic gases from Io, the faint fingerprints of Europa's ocean, the echoes of Ganymede's magnetic defiance. These particles travel outward, trapped in the tail's magnetic lanes, until they are flung into deep space or drawn back toward the planet. Sometimes the tail snaps. When magnetic field lines become too stretched, they break and reconnect, releasing bursts of energy that send particles flying in all directions. Spacecraft have caught glimpses of these events, sudden flares and radio waves, brief storms of electrons and ions. To be caught in such a moment would be to witness an invisible lightning strike spanning millions of kilometers. The magnetotail also has a strange relationship with the moons. As the moons pass through it, they disturb its shape, creating ripples and twists that can travel vast distances. Io's volcanic gases, once ionized, can find their way here, forming luminous sheets of plasma drifting in the dark. Europa's faintly induced magnetic field leaves a subtle signature, a faint bend in the tail's flow. To the sun, Jupiter's magnetotail is a defiance, a place where the solar wind's will is resisted, bent, and redirected. The planet's magnetic field holds the wind at bay, refusing to surrender its hold over the space around it. But the tail is also a connection, a bridge of magnetism linking Jupiter not only to its moons, but to the greater dance of the solar system. If you could see it, really see it, the magnetotail would be a river of ghost light flowing into the night. It would shimmer faintly, shifting as the solar wind's speed and direction changed, twisting and unfurling like the tail of a great cosmic kite. The sight would be silent, yet full of motion, a living reminder that even in the seeming emptiness of space, there are currents as real as those in any ocean. Far along the tail, near its distant edges, the magnetic field begins to weaken. The sun's influence grows stronger here, bending and fraying the edges of the structure. Eventually, the tail strands are lost to the interplanetary wind, their particles drifting off into the vastness between the planets. Some may journey to Saturn's domain, mingling with the charged particles there. Others may be drawn back toward Jupiter, spiraling inward along field lines to crash into the planet's upper atmosphere in a final burst of auroral light. From a human perspective, the magnetotail is a challenge to comprehend. We are accustomed to thinking of objects as self-contained, a planet as a sphere, a moon as a rock, a star as a ball of fire. But Jupiter teaches us that worlds are not islands. They extend themselves into space in ways our eyes cannot detect, through gravity, through radiation, through invisible magnetic hands that reach out far beyond what we would expect. The magnetotail is Jupiter's shadow, but it is not made of darkness. It is made of motion, of energy, of particles older than Earth itself. It is the product of a conversation between planet and star, between rotation and wind, between the quiet churn of a metallic heart deep within Jupiter and the endless gusts of the sun's breath. In this shadow, there is a reminder: the solar system is not static. It is a sea of forces and fields, a place where boundaries are soft and invisible, shapes stretch far beyond the worlds they belong to. The magnetotail is Jupiter's silent claim over a slice of that sea, a signature scrawled in magnetism, reaching farther than our minds can comfortably hold. And if you could follow it, if you could drift along its length, from Jupiter's night side all the way to its fading edge, you might feel as though you were moving down the spine of a great celestial creature, its body disappearing into the deep dark between the planets. You would pass through regions where particles raced like invisible rain, where magnetic lines bent and snapped, where the sun's breath and Jupiter's field tangled in an endless contest. You would emerge finally into the place where the tail dissolves into the interplanetary wind, where the giant's influence fades and the currents of space flow freely again. And you would know then that even in absence, Jupiter is present, its shadow still trailing far behind, carried onward by the wind of the sun. At the crown and base of Jupiter's spinning sphere, something extraordinary happens. Here, where magnetic field lines plunge into the atmosphere, the invisible becomes visible. These are the auroras, rings of light that circle the poles like glowing halos, not fleeting like those on Earth, but almost permanent, a ceaseless crown of fire. They pulse, shimmer, and twist with a rhythm set by forces far beyond the clouds. On our own world, auroras come and go. They arrive when the solar wind disturbs our magnetosphere, then fade into darkness when the disturbance passes. But on Jupiter, they burn almost without end. This is because Jupiter's auroras are not fed solely by the sun, they are powered from within. Deep in the giant's core, metallic hydrogen spins at incredible speed, generating a magnetic field so vast it traps and accelerates charged particles relentlessly. These particles are funneled along magnetic lines toward the poles, where they plunge into the upper atmosphere, colliding with atoms of hydrogen. The collisions release energy as light in ultraviolet, invisible wavelengths in X-rays. To human eyes, much of Jupiter's auroras would be invisible. They burn brightest in ultraviolet, a color beyond our seeing. Yet spacecraft like Hubble and Juno have peered into this hidden glow, revealing loops, swirls, and pulses that ripple across the poles in shapes as dynamic as any storm. Some of the pulses are steady, like the beat of a drum. Others are sudden, like the snap of a lightning strike. The auroras respond not only to the sun's wind, but to the restless moons in their orbits. Io, in particular, acts as a spark. Its volcanic plumes spew charged sulfur and oxygen into space, which then flow along magnetic field lines into Jupiter's poles, creating brilliant hot spots of auroral light that follow the moon's path. It is as though the moon and the planet are connected by an invisible filament, a glowing tether of magnetism that writes Io's presence into the sky. Europa and Ganymede too leave their marks, smaller, subtler, but no less real. In this way, Jupiter's auroras are not solitary. They are a collaboration between planet, moons, and star. When storms rage in the magnetotail, when stretched field lines snap and reconnect, their echoes travel toward the poles, feeding bursts of energy into the auroral ovals. These events can create flickers and surges that sweep across the polar skies, momentary waves of brightness that roll over the planet's head like the breath of an unseen wind. And then there are the X-ray auroras, mysterious pulses of high-energy light that flash every few minutes, concentrated over the poles in precise spots. The cause of these pulses puzzled scientists for years. It is now thought that they may be tied to the way charged particles spiral inward from the far reaches of the magnetosphere, guided by waves in the magnetic field itself. It is a reminder that even in a system as vast as Jupiter's, rhythms and patterns emerge, as if the giant planet has a heartbeat. If you could stand, impossibly, beneath these auroras and look up, the experience would be overwhelming. The ovals of light would stretch from horizon to horizon, rippling with colors too strange for human eyes to name. Some would pulse gently, others would flare suddenly, their brightness casting fleeting shadows across the clouds. You would feel the crackle of energy in the air, though no sound would reach you. The music of this light is silent, carried only by the shifting of particles and fields. From space, the view is different, but no less wondrous. The auroras encircle the poles like living crowns, their light flaring and fading in complex patterns that seem to tell a story. The story of a planet locked in eternal conversation with its star and its moons. To scientists, Jupiter's auroras are not just a spectacle. They are a window into the planet's hidden engine. By studying their light, we can trace the flow of energy from the solar wind into the magnetosphere, from the planet's rotation into the acceleration of particles, from volcanic plumes on distant moons into the skies of the giant itself. The auroras are the surface ripples of a deep and unseen ocean of forces. But to the poetic mind, they are something more, a sign that even in the cold darkness of the outer solar system, there is beauty that burns with its own fuel. Unlike Earth's auroras, which depend on chance encounters with solar storms, Jupiter's auroras are self-sustaining, a continuous act of creation. They are the visible breath of a world whose magnetic heart never stops beating. And as long as Jupiter spins, as long as metallic hydrogen churns in its depths, as long as moons dance through its magnetic grasp, these polar crowns will keep shining, not for days, not for years, but for eons. The vast magnetic field of Jupiter is not a lonely dominion. It is threaded with voices. Each moon speaks into it, some softly, some with a shout, and their words are written in light, in charged particles, in subtle waves that travel through the giant's invisible reach. To stand in this magnetic realm, if such a thing were possible, would be to feel a constant presence, not silence, not emptiness, but the sensation of an ocean whose currents carry messages back and forth. Each moon in its orbit disturbs these currents, leaving ripples that can be felt across millions of kilometers. Io, the most volcanic body in the solar system, is the loudest of them all. Its restless surface vents plumes of sulfur and oxygen high above its thin atmosphere, releasing clouds of charged particles into space. These particles are immediately caught in Jupiter's magnetic field, spiraling along invisible pathways toward the poles. There, they ignite as bright fixed spots in the auroras, luminous fingerprints of Io's orbit. The connection is electric, quite literally. The motion of Io through the magnetic field generates a current of about 3 million amperes, linking moon and planet like a cosmic dynamo. This current travels along magnetic flux tubes, unseen wires of force, that carry energy and particles in both directions. It is as if Jupiter and Io are locked in a slow, eternal handshake, the grip never loosening. Europa, colder and quieter on the surface, speaks in gentler tones. Beneath its icy shell, an ocean of salt water is thought to lie in darkness. As Europa moves through the magnetosphere, the conductive salt water interacts with Jupiter's field, generating subtle signals, magnetic echoes that spacecraft can detect. These whispers suggest the ocean is real and that it moves, tides shifting under the pull of Jupiter's gravity. Europa's auroral footprint is fainter than Io's, but it is steady, a constant reminder of the hidden sea's presence. Ganymede is unique among moons. It has a magnetic field of its own, the only moon in the solar system known to possess one. This means Ganymede's voice in Jupiter's magnetic empire is complex, layered. The moon's own field carves out a tiny magnetosphere within Jupiter's much larger one, creating boundaries, shocks, and reconnection events on a miniature scale. When Ganymede moves through Jupiter's charged particle streams, sparks of interaction flare, a quiet but intricate conversation between magnetic worlds. Callisto, ancient and cratered, orbits far from the turbulent inner reaches of the magnetosphere. Yet even here, the field's reach is felt. Callisto's surface and thin atmosphere interact weakly with Jupiter's magnetic breath, creating delicate disturbances. Its voice is the faintest, almost a sigh, but in the great symphony of the Jovian system, every note matters. From Jupiter's perspective, these moons are not passive companions. They are active participants in the shaping of its space environment. The planet's magnetosphere is not a static bubble, but a living, shifting structure, constantly reshaped by the gravitational pulls and particle streams of its moons. The flux tubes that connect Jupiter to Io, Europa, and Ganymede are like filaments of silk, invisible to the eye, but strong enough to carry torrents of energy. Spacecraft have traced these connections in exquisite detail. Juno, orbiting close, has flown through the currents themselves, measuring their strength and mapping the auroral footprints they create. Each moon's footprint drifts across the polar skies, glowing in ultraviolet light, marking where the magnetic tether meets the atmosphere. The footprints move with the moons, like reflections dancing across water. From a poetic view, these magnetic connections are not just physical, they are relationships. Jupiter is the center, the great heart, and its moons are bound to it, not only by gravity, but by streams of energy that pass between them like messages in a shared language. Some messages are urgent and bright, like Io's volcanic outbursts. Some are quiet and constant, like Europa's hidden ocean. Some are complex and shifting, like Ganymede's double field. And some are sparse, like Callisto's distant murmur. If you could listen, not with ears, but with instruments tuned to the low, slow frequencies of the magnetosphere, you might hear the changing tones of this planetary choir, the hum of Jupiter's rotation, the staccato bursts of Io's volcanic currents, the subtle modulation of Europa's ocean-induced field, the strange layered harmonics of Ganymede's independent magnetism, all woven into a single composition that never stops playing, even in the deepest night of the solar system. And these whispers have existed for billions of years. Long before Earth's first forests, before even the oldest rocks still standing on our planet, Jupiter and its moons were already bound together in this magnetic web, exchanging particles, energy, and silent light. Their conversation is ancient, patient, and ongoing. One day, if we send explorers to these moons, to walk the ice of Europa, to taste the plumes of Io, to measure the fields of Ganymede, they will be stepping into this invisible network. Every landing, every orbit will be made within a sea of magnetic threads stretching between worlds. In this way, Jupiter's moons are not merely orbiting stones. They are nodes in a system of living magnetism, co-creators of the auroras, sculptors of the particle streams, and keepers of ancient interactions. Each orbit, each spin, each volcanic breath and ocean tide leaves its mark in the great field that holds them all. And as long as the giant spins and the moons keep their pace, these magnetic whispers will continue, a chorus of worlds speaking across the darkness, tied together by threads of force no eye can see, but whose effects light up the poles of a planet 400 million miles from the sun. In the deep darkness beyond Jupiter's glowing clouds, its magnetic field stretches outward, away from the sun, into a form so vast that no human eye could ever take it in. Here lies the magnetotail, an immense, invisible river of magnetism trailing behind the planet like the streaming tail of a comet. To call it large is to speak in understatement. Jupiter's magnetotail extends millions of kilometers into space, farther than the orbit of Saturn at times. A colossal wake of charged particles and field lines dragged away by the constant pressure of the solar wind. Where the sun's breath meets Jupiter's shield, the field is squeezed on the day's side, but on the night's side, it is pulled into a long, tapering plume that vanishes into the black. If one could drift within it, a silent traveler in the dark, you would not see walls or floors, but you might feel it in ways not meant for skin or bone. You would feel the soft, steady pull of field lines guiding particles like streams in a current. You would sense the flow of ions and electrons, some born in the volcanoes of Io, others captured from the solar wind, all moving together in long, slow spirals into the distance. This magnetotail is no mere afterthought to Jupiter's magnetosphere. It is a dynamic engine of motion and transformation. Here, particles accelerate to incredible speeds, guided by the shape and pressure of the tail. Bursts of energy, magnetic reconnection events, release sudden waves of motion, sending streams of particles back toward the planet's poles, where they erupt in bright auroras. Others are flung outward, hurled into interplanetary space, never to return. Like a comet's tail, it always points away from the sun, regardless of Jupiter's spin. As the planet orbits through the solar system, the magnetotail sweeps through the void like a gigantic paintbrush, invisibly stroking the dark with magnetic color. If it were visible, it might shimmer faintly, a ghost of light stretching for millions of kilometers, a banner proclaiming the giant's reach. The moons too feel the magnetotail's influence. In certain alignments, they pass through its heart, bathed in its slow-moving plasma. Io's volcanic gases can be carried deep into the tail, scattered across unimaginable distances. Europa's tenuous oxygen atmosphere leaves faint imprints here, as if the moon has signed its name in the flowing field. Even distant Callisto is not beyond its touch. The tail is patient, reaching farther than the mind comfortably holds. The magnetotail is also a memory keeper. Within its plasma are particles that have traveled from the planet's poles, from the inner moons, from the sun itself. These particles can remain trapped in the tail for weeks, months, even years, spiraling slowly along the stretched field lines. To study them is to read a time capsule of Jupiter's magnetic and atmospheric history, written not in ink, but in electric charge. Spacecraft have ventured into this strange domain. Voyager 2 first felt its vastness in 1979, passing through regions where the field lines bent and shifted, and where the particle counts rose and fell in slow rhythms. Decades later, other missions confirmed its scale, that this was not a narrow streamer, but a titanic structure so broad that Earth itself could vanish within it many times over. In the far reaches of the magnetotail, where the influence of Jupiter's field finally weakens into the background of the solar system, something almost philosophical happens. Here, the line between Jupiter's domain and the sun's becomes blurred. The magnetic signature of the giant slowly fades, its lines merging with the solar wind's vast interplanetary field. It is as if the planet exhales its influence into the greater breadth of the solar system, its tail becoming part of a far larger current. To the poetic eye, this magnetotail is Jupiter's shadow in the language of magnetism, a presence that stretches behind it, always unseen but real, a consequence of its power and its dance with the sun. It is the trail of its journey, a proof of its interaction with the greater forces that move all worlds. And yet, like much of space, it is empty and full at the same time. Empty of matter dense enough to touch, but full of motion, of energy, of patterns too slow for the human heart to notice without patient measurement. In this tale, charged particles make their pilgrimage, some returning home to spark auroras, others vanishing into interstellar night. When the sun is active, when solar storms blast outward with sudden ferocity, the magnetotail feels it. Compressed, twisted, and energized, it becomes a place of turbulence, like a great river struck by a sudden storm. Reconnection events multiply, and the auroras at Jupiter's poles brighten and dance more fiercely, responding to the pulse that has traveled all the way down the invisible tail to the planet itself. And so the magnetotail is not static. It is alive in the slow way of giant things. It breathes with the rhythm of Jupiter's rotation, with the changes in the solar wind, with the contributions of the moons. It is at once a shield, a highway, and a storyteller, carrying Jupiter's influence far from the planet's glowing disk. If you could follow it to its very end, you would find no sharp boundary, no wall where it stops. Only a fading, a merging into the deep currents of the solar system. Jupiter's magnetotail does not end so much as it becomes part of everything else, like the last notes of a song that dissolve into silence, not gone, but transformed into something larger. Between the Sun and Jupiter, there is a dialogue, though not in words, and not in any language that human ears can hear. It is a dialogue spoken in magnetic fields and charged particles, in flows of invisible wind that cross the void. A conversation that has continued for billions of years, unbroken and unending, yet always changing in tone. The sun's breath, the solar wind, streams outward in all directions, carrying with it the interwoven threads of the sun's magnetic field. This wind is constant, yet never still. It gusts and lulls, it shifts and eddies, shaped by the sun's moods. And far from the sun's light, more than 778 million kilometers away, Jupiter waits, a giant whose own magnetic field is so strong that it reshapes this wind, carving out a vast protective bubble in space. Where they meet, there is tension. The solar wind presses inward, trying to collapse Jupiter's shield. Jupiter's magnetosphere pushes outward, resisting, flexing, and shifting to keep the sun's breath at bay. This boundary, the magnetopause, is not a fixed wall, but a living frontier. At times, under gentle solar winds, it swells outward, granting Jupiter a greater domain. At other times, under the impact of powerful solar storms, it is pushed inward, compressed until Jupiter's defenses are tested to their core. It is a dance, but also a duel. And in this cosmic choreography, there are no spectators. Every moon, every charged particle, every auroral glow at the poles is part of the performance. When the solar wind is calm, Jupiter's magnetosphere hums in quiet stability. The auroras at the poles shimmer steadily, fed mostly by the volcanic gases of Io, which are drawn along the planet's magnetic field lines. The flow is smooth, the boundaries clear. In these moments, Jupiter stands like a fortress in the void, unshaken by the slow breath of the sun. But when a coronal mass ejection bursts from the sun, racing across the solar system, the dance changes. The solar wind arrives like a sudden gale, its density and speed magnified, its magnetic field more turbulent. Jupiter's magnetopause bends inward, its shape distorted. The compressed field lines in the magnetotail snap and reconnect, releasing enormous bursts of energy. The auroras surge with sudden brightness, swirling and flickering in colors invisible to the human eye, but brilliant to the instruments that can see them. These storms are not rare. They are part of the natural heartbeat of the solar system. The Sun and Jupiter know them well, as partners in this dance, having known each other's strengths and temperaments for eons. And yet, every encounter is unique. The solar wind never repeats itself exactly. Its magnetic field orientation changes, its density shifts, and the giant responds in kind, adjusting, flexing, adapting in the slow, powerful way that only worlds of such size can. From a human perspective, it is tempting to think of Jupiter as the passive partner, standing still while the solar wind does the moving. But the truth is more subtle. Jupiter's rotation, a swift 10 hours, whips its magnetic field into a spinning dynamo, feeding currents that flow through the entire magnetosphere. These currents influence how the solar wind's energy is absorbed and redistributed. Jupiter is not merely shaped by the wind. It shapes the wind in return, redirecting flows of charged particles, sending waves rippling far downstream into the solar system. In the quiet between storms, the solar wind still leaves its mark. Particles from the sun are captured, guided down magnetic field lines into Jupiter's atmosphere. There, they collide with atoms of hydrogen, producing ultraviolet light in delicate rings and arcs. These auroras are constant, a sign that the sun's influence is never entirely absent. Even at its calmest, the solar wind is always touching Jupiter, always part of the dance. The moons play their part too. As Io, Europa, Ganymede, and Callisto orbit within and beyond Jupiter's magnetic field, they alter the flows of plasma and magnetic energy. When a moon's orbit carries it into the path of particles driven by the solar wind, it can create wakes and disturbances, shaping how the energy moves through the system. In this way, the dance is not only between two giants, but a waltz performed by an entire celestial family. If we could stand above it, far above, looking down on this interaction in some form of invisible sight, we might see Jupiter's magnetic bubble swaying and pulsing in time with the solar wind's breath. We might see bright auroral ovals flashing like slow heartbeats. We might see the magnetotail stretching and relaxing, like a ribbon caught alternately in calm air and in gusts. And beyond all of it, the sun would shine, distant, yet still the conductor of this silent orchestra. It is humbling to realize that this is not just Jupiter's story. Every planet, every world, even tiny Mercury, is caught in the solar wind's touch. But Jupiter's dance is the grandest, the most elaborate, a performance on a scale so vast that human senses cannot truly grasp it without the aid of instruments and imagination. And yet, imagination may be the truest way to experience it. For in the mind's eye, we can stand at the edge of the magnetopause, feeling the steady pressure of the solar wind on one side and the vast rotating shield of Jupiter on the other. We can watch field lines bend and snap, auroras flare and fade, particles race and spiral into the deep tail. We can feel the rhythm, a slow, patient exchange of energy that has been ongoing since before there were eyes to see it, before there were minds to wonder about it. In this way, the dance of Jupiter and the solar wind is both ancient and eternal. It will continue long after the current storms have faded, long after our instruments have gone silent. It is a motion written into the fabric of the solar system itself, a ballet of giants, choreographed by magnetism, powered by light, and performed in the endless darkness of space. Between the Sun and Jupiter, there is a dialogue, though not in words, and not in any language that human ears can hear. It is a dialogue spoken in magnetic fields and charged particles, in flows of invisible wind that cross the void. A conversation that has continued for billions of years, unbroken and unending, yet always changing in tone. The sun's breath, the solar wind, streams outward in all directions, carrying with it the interwoven threads of the sun's magnetic field. This wind is constant, yet never still. It gusts and lulls, it shifts and eddies, shaped by the sun's moods. And far from the sun's light, more than 778 million kilometers away, Jupiter waits, a giant whose own magnetic field is so strong that it reshapes this wind, carving out a vast protective bubble in space. Where they meet, there is tension. The solar wind presses inward, trying to collapse Jupiter's shield. Jupiter's magnetosphere pushes outward, resisting, flexing, and shifting to keep the sun's breath at bay. This boundary, the magnetopause, is not a fixed wall, but a living frontier. At times, under gentle solar winds, it swells outward, granting Jupiter a greater domain. At other times, under the impact of powerful solar storms, it is pushed inward, compressed until Jupiter's defenses are tested to their core. It is a dance, but also a duel. And in this cosmic choreography, there are no spectators. Every moon, every charged particle, every auroral glow at the poles is part of the performance. When the solar wind is calm, Jupiter's magnetosphere hums in quiet stability. The auroras at the poles shimmer steadily, fed mostly by the volcanic gases of Io, which are drawn along the planet's magnetic field lines. The flow is smooth, the boundaries clear. In these moments, Jupiter stands like a fortress in the void, unshaken by the slow breath of the sun. But when a coronal mass ejection bursts from the sun, racing across the solar system, the dance changes. The solar wind arrives like a sudden gale, its density and speed magnified, its magnetic field more turbulent. Jupiter's magnetopause bends inward, its shape distorted. The compressed field lines in the magnetotail snap and reconnect, releasing enormous bursts of energy. The auroras surge with sudden brightness, swirling and flickering in colors invisible to the human eye, but brilliant to the instruments that can see them. These storms are not rare. They are part of the natural heartbeat of the solar system. The Sun and Jupiter know them well, as partners in this dance, having known each other's strengths and temperaments for eons. And yet, every encounter is unique. The solar wind never repeats itself exactly. Its magnetic field orientation changes, its density shifts, and the giant responds in kind, adjusting, flexing, adapting in the slow, powerful way that only worlds of such size can. From a human perspective, it is tempting to think of Jupiter as the passive partner, standing still while the solar wind does the moving. But the truth is more subtle. Jupiter's rotation, a swift 10 hours, whips its magnetic field into a spinning dynamo, feeding currents that flow through the entire magnetosphere. These currents influence how the solar wind's energy is absorbed and redistributed. Jupiter is not merely shaped by the wind. It shapes the wind in return, redirecting flows of charged particles, sending waves rippling far downstream into the solar system. In the quiet between storms, the solar wind still leaves its mark. Particles from the sun are captured, guided down magnetic field lines into Jupiter's atmosphere. There, they collide with atoms of hydrogen, producing ultraviolet light in delicate rings and arcs. These auroras are constant, a sign that the sun's influence is never entirely absent. Even at its calmest, the solar wind is always touching Jupiter, always part of the dance. The moons play their part too. As Io, Europa, Ganymede, and Callisto orbit within and beyond Jupiter's magnetic field, they alter the flows of plasma and magnetic energy. When a moon's orbit carries it into the path of particles driven by the solar wind, it can create wakes and disturbances, shaping how the energy moves through the system. In this way, the dance is not only between two giants, but a waltz performed by an entire celestial family. If we could stand above it, far above, looking down on this interaction in some form of invisible sight, we might see Jupiter's magnetic bubble swaying and pulsing in time with the solar wind's breath. We might see bright auroral ovals flashing like slow heartbeats. We might see the magnetotail stretching and relaxing, like a ribbon caught alternately in calm air and in gusts. And beyond all of it, the sun would shine, distant, yet still the conductor of this silent orchestra. It is humbling to realize that this is not just Jupiter's story. Every planet, every world, even tiny Mercury, is caught in the solar wind's touch. But Jupiter's dance is the grandest, the most elaborate, a performance on a scale so vast that human senses cannot truly grasp it without the aid of instruments and imagination. And yet, imagination may be the truest way to experience it. For in the mind's eye, we can stand at the edge of the magnetopause, feeling the steady pressure of the solar wind on one side and the vast rotating shield of Jupiter on the other. We can watch field lines bend and snap, auroras flare and fade, particles race and spiral into the deep tail. We can feel the rhythm, a slow, patient exchange of energy that has been ongoing since before there were eyes to see it, before there were minds to wonder about it. In this way, the dance of Jupiter and the solar wind is both ancient and eternal. It will continue long after the current storms have faded, long after our instruments have gone silent. It is a motion written into the fabric of the solar system itself, a ballet of giants, choreographed by magnetism, powered by light, and performed in the endless darkness of space. Its light floods the solar system with energy, its wind brushes every planet, and its gravity binds all worlds in a slow, eternal dance. Jupiter's magnetosphere, vast, powerful, restless, lives in this context, shaped by the warmth and the breath of our star. But nothing in the cosmos lasts forever. The sun's life is long by human measure, but finite in the language of stars. And in the far reaches of time, changes will come, not sudden to a planet, but unfolding over millions of years, like the turning of an ancient page. We imagine this future not in years or centuries, but in epochs. Billions of years from now, the sun will swell into a red giant. Its light will change, deepening toward the crimson, its warmth stretching outward to embrace worlds now cold and distant. Jupiter, for a time, will lie under a red sky, its clouds tinted with the glow of an aging star. The solar wind will change too. It will be denser, more chaotic, more laden with particles as the dying sun sheds its outer layers into space. This storm of stellar breath will buffet Jupiter's magnetosphere, pushing, reshaping, and possibly compressing it. Yet Jupiter's magnetic field, born from the churning of metallic hydrogen deep in its heart, will still stand, a bulwark against the charged tide. In fact, without the sun's steady, calmer wind, the magnetosphere might even expand during certain phases, ballooning far into the void. But this will be a restless time, the balance between Jupiter and its star rewritten day by day. In this altered light, Jupiter's moons will also change. Europa's ice might begin to melt on the surface, briefly exposed to liquid water under the dim warmth of the red giant sun. Ganymede's own magnetic field will dance within Jupiter's greater one, producing auroras stranger than anything we can now imagine. Pale red curtains rippling across an alien sky. Io's volcanoes, already furious, might erupt more violently if tidal forces shift with changes in Jupiter's orbit or the sun's mass loss. Each burst of volcanic gas would feed new material into Jupiter's magnetosphere, adding to its auroral fires. The entire Jovian system will become a place of extremes. Magnetic storms fueled not only by the sun, but by the moons themselves. Eventually, the sun will cast off its outer layers entirely, leaving behind a white dwarf, a small, dense ember of what was once a star. The solar wind will be gone, replaced by the quiet radiation of this stellar remnant. In that age, Jupiter's magnetosphere will expand greatly, no longer pressured by a strong solar wind. Without that constant push, its magnetic field will reach farther into interplanetary space, a ghostly bubble in the dark, and the night will be nearly absolute. No storms of solar particles to dance at the poles, no constant interplay between sun and planet. Jupiter's auroras will fade, sustained only by the occasional breath of plasma from Io or from interstellar particles drifting in from beyond the solar system. The giant will remain magnetic for a long time still, its interior heat and rotation keeping the metallic hydrogen flowing. But even Jupiter will not last forever. Slowly, so slowly that no single moon could notice, the planet's heart will cool. The motions that generate its magnetic field will weaken. In the deepest reaches of time, perhaps trillions of years hence, Jupiter's dynamo will finally still. The magnetic field will fade, and the magnetosphere will collapse inward until it is gone. The moons will drift on, unshielded, into the quiet of space. This will be the end of the giant's voice. No more radio bursts, no more auroras, no more invisible shields sweeping through the dark. Jupiter will be a silent world, lit faintly by the dead star it still orbits. And yet, even in this silence, something of the magnetosphere's story will endure. It will remain in the scars on Io's surface, in the ancient ice of Europa, in the faint traces of radiation deep within Ganymede's crust. The moons will remember, in their geology and in their histories, that once there was a magnetic giant here and that they lived within its vast protection. There is a final thought, one that belongs to the realm of speculation. The sun's slow loss of mass will loosen its grip on its planets. Some may drift outward. Others may be pulled away entirely by the passing of other stars. In that great shuffle, Jupiter might one day be set adrift, carrying its moons into interstellar space. In the darkness between the stars, a rogue Jupiter would keep its magnetic field for as long as its heart remained warm enough. Its magnetosphere would be unchallenged by any solar wind, stretching out quietly, invisible in the cosmic night. It would be a solitary guardian, its power unseen, its story untold, except to the moons it carried. And when at last the magnetic field was gone, Jupiter would still circle on in the dark, not longer a giant with a voice, but a monument to the worlds that once were. In the endless night of the far future, Jupiter's magnetosphere will pass from power to memory. But here and now, in this brief age where the sun still shines and spacecraft still fly, we can hear its voice, study its patterns, and marvel at the fact that we live in a time when the giant still speaks. It is a gift of timing, a fleeting overlap between human curiosity and planetary vitality. And like all gifts in the cosmos, it will one day fade, but not before it has been heard.